Hi, everyone. We're now going to graph tangent and cotangent graphs more generally for transformed functions. So we're going to go back to the frame method, PCAPIA, and I'm going to discuss the cycle grid. What are the possible cycles that we're going to draw in our frame method? Well, it depends if we have tangent versus cotangent, and if the value of A, which is the letter before tangent or cotangent, the number before tangent or cotangent, it depends if it's positive or negative. We're going to graph equations of these forms here. A is like a coefficient before tangent or cotangent, and it matters, like before, if A was positive or negative. A cannot be zero. If A is positive, then all is good. We have rising tangent snakes and falling cotangent snakes. But if A is negative, then we flip. So tangent goes from rising to falling, and cotangent goes from falling to rising. So basically, for tangent and cotangent graphs, we're either going to get a rising snake going tic-tac-toe through these three key points, or a falling snake going tic-tac-toe through these three key points. Remember that for tangent, the pivot corresponding to the origin, maybe where the origin used to be, that corresponds to the central point of the frame, while for cotangent and the other trig functions, the pivot is back to the left center point. In the cotangent case, the pivot is not a point on the graph. For tangent, the pivot will be a point on the graph. But basically, there are two cycle shapes. The pivot is located differently for the two functions. All right. We're going to use the frame PCAPIA method to graph equations of this type. Y equals a non-zero number times tangent or cotangent of a linear function of x, all plus d. Now, what are some modifications with respect to the sine and cosine graphs that we did before? Okay, well, we're going to have different cycles. We have different cycles. Sine and cosine had pieces of waves. Here we have snakes. Also, tangent and cotangent technically have no amplitude because remember, these snakes were infinitely tall. Instead, I'm going to talk about a frame amplitude, and that's given by the absolute value of A. So instead of amplitude, I'm going to refer more to a frame amplitude, which is half the height of the overall frame. So basically, the frame amplitude would be this height over here, half the height of the frame. This helps us get the quarter points on the graph. The period is given not by 2 pi over b, but by pi over b. Remember that the period for the basic tangent and cotangent functions, the period was pi in both cases. It was 2 pi for sine and cosine. Later on, when we graph something like this, where b is the coefficient on x basically, the period in general is given by pi over b. If b is negative, then you want to use the odd property of tangent or cotangent first. If b is not positive right now, then use the absolute value of b down below. The period is always positive. But for tangent and cotangent, we're going to use that the period is pi over b, not 2 pi over b, which is the case for sine, cosine, and also cosecant and secant. Now, when drawing a cycle for a tangent graph, remember that the pivot, PD, is going to be the central point of the frame, the center point. It's the left center point for all 5 of the others, including cotangent. That will correspond to the origin, or the origin used to be. Okay, let's now look at an example. Use the frame method if you wish. If you don't use the frame method, then give me all the information the frame method would have given me. Use the frame method to graph one cycle of the graph of y equals 2 tangent of 2/5 x all minus 3. There are infinitely many possible cycles, but the frame method will suggest one. Now, first of all, notice here that b, the coefficient on x, is positive. B equals 2/5, which is positive. That's great news for us, because if b were negative, we'd have to use the odd property for tangent or cotangent functions. If we had a negative 2/5 x, for example, then the negative sign we'd need to pop out. Here, b is positive, no problem. Remember that both tangent and cotangent are odd. Let's find the pivot. Where does the origin move to? What is the phase shift? Well, to find the phase shift, you set the argument here, 2/5 x, equal to 0. Where does 2/5 x equal to 0? Here, it's straightforward. X equals 0. This happens when x equals 0. Two-fifths x equals 0 when x equals 0. So there's no phase shift. There's no horizontal shift. If you want, you could add or subtract by the period, but there's no need to do that here. If the phase shift can be said to be 0, we'll use 0. Now, what about the vertical shift? We just pull that directly from here. It's this constant term on the right side. That's the vertical shift, -3. We shift the graph down by 3 units. So the origin is basically moved down to the point 0, 3. And remember, the pivot for tangent corresponds to the central point, the center point of the frame. 0 is here. -3 is over here. Here's P. Here's D. The origin moves down 3 units. We're at the point 0, -3 for the pivot, the central point. Now from the -3, this is D now, how do we get the y-coordinate for the top line of the frame and then the bottom line of the frame? Well, the frame amplitude is 2. Remember, we look at the number in front of tangent here, a equals 2. That's the frame amplitude. There's no overall amplitude because this snake is infinitely tall, but the frame here has an amplitude. Half the height of the frame is 2. So, to get the y-coordinate of the top line, we take -3 and add 2. -3 plus 2. -3 plus 2 is -1. So -1 corresponds to the top line segment. To get the y-coordinate for the bottom line segment, we take the -3 and we subtract the 2. We get -5. So -5 is the y-coordinate for the bottom line segment of the frame. Okay, so we have a good idea of the y-coordinates we need to work with for the key points. Now, what about the theta, or in this case, the x-coordinates? We're back to x-coordinates. What about the x-coordinates? Well, first, we're going to need the period. How do we get the period? The period is given by not 2 pi over b, but pi over b. Remember, b is now positive. The period is given by pi over b. Pi over, well, what was b? The coefficient on x was 2/5. It was the 2/5 over here. Pi over 2/5. When you divide by 2/5, you multiply by the reciprocal of 2/5, which is 5/2. So we get 5 pi over 2. Pi divided by 2/5 is pi times 5/2. That's 5 pi over 2, and that's the period. Do we put 5 pi over 2 here at this VA? The answer is no, because 0 is not at the left edge, it's at the center. So we do not put 5 pi over 2 anywhere over here. Instead, we're going to use the increment. For all 6 trig functions, we cut the period into quarters. We take 1/4 of the period. 1/4 times 5 pi over 2. We multiply across, we get 5 pi over 8. That's the increment. That's the number that we're going to add and subtract in this case to get the various x coordinates for our frame. All right, at this point, I'm going to go straight to the answer. So we have 0 in the middle. 0 plus the increment, 5 pi over 8, is 5 pi over 8. That's the x-coordinate for this key point here. 5 pi over 8 plus 5 pi over 8 is 10 pi over 8. That simplifies to 5 pi over 4. Don't forget to simplify. You can see that 5 pi over 4 is half of the period, 5 pi over 2, because we're getting half the period from here to here. And then we could use symmetry about 0 to get the x-coordinates over here. This is negative 5 pi over 8. Over here, this is negative 5 pi over 4. It's convenient that we have 0 in the center. If the phase shift were not 0, if there were some phase shift, then we would actively have to subtract. We would subtract the increment, subtract 5 pi over 8, subtract 5 pi over 8. So where does the period actually come in? Well, if you want to do a check, the period is the distance, the total width. It's the distance between the two VAs here. 5 pi over 4 minus negative 5 pi over 4 is 10 pi over 4, or 5 pi over 2, the period. So the period is hidden in the graph here. PCAPIA. Don't forget the final A for PCAPIA. Superimpose the coordinate axes. The x-axis, don't forget to put the x at the right end. The x-axis corresponds to y equals 0. Now, where's y equals 0? Well, 0 is above all these negative numbers over here. These are the y coordinates we picked up before for the key points. Y equals 0 is above the entire frame, in fact. Now, I'm not going to get a ruler. As long as you put the x-axis above the frame, above the negative 1 in particular, then I'm happy. The y-axis has equation x equals 0. Well, it's right through the middle here. Here's 0. Put the y at the top, not the bottom, put the y at the top of this vertical line. And we're done. We have one cycle for the given tangent function. We know the VAs are over here at x equals 5 pi over 4 and x equals negative 5 pi over 4. We could read off the points of these tic-tac-toe key points. And we have the axes here. By the way, one advantage for superimposing the axes at the end is that if we started by putting x and y axes, then it might be a struggle to try to locate these key points. We'd have to worry what quadrant are we in and all that. So it might actually be harder to fit these points into this coordinate system where the axes are already there. I think it's easier to do the axes at the end. Superimpose the axes at the end, but don't forget them. Don't forget to put on the x and y axes. But it's easier to put them on at the end. The x-axis has equation y equals 0. The y-axis has equation x equals 0. Now again, for all tangent graphs, I'm going to put the pivot at the center. If you choose to put the pivot at the left center, which you could do, then what's going to happen is that you are going to get a vertical asymptote in the middle here. So you're going to get half a snake here and half a snake here. And that's going to be ugly. That's going to work, but it's going to be ugly. Another way that you can do this is that in their trig classes, some students actually find the VAs first. Remember, we found the pivot, in particular the phase shift P, by setting the argument equal to 0. We set 2/5 x equal to 0, and we got x equals 0. That was the phase shift P. Now, if you wanted to find the VAs first, Well, you could set the argument 2/5 x equal to negative pi over 2, which is where the VA used to be, and at positive pi over 2, which is where another VA used to be, and solve for x. And then you'd get negative 5 pi over 4 and positive 5 pi over 4. But I think that's more work. It does work, but it's more work, I think, instead of just figuring out that the 0 is in the center here. For cotangent, by the way, the old VAs were at 0 and at pi. But again, I think it's easier if we place the pivot smack dab in the center and focus on the pivot. The phase shift P is obtained by setting the argument equal to 0 and solving for x. Here, we get x or P equals 0. There is no phase shift. There is no horizontal shift. Although if you wanted to shift by the period to the left or to the right, you get an appropriate cycle. Next up, how do we graph cosecant and secant functions? Next time.